Hello guys, in this video I'll show you how to solve complement of base 10 number. So every non-negative integer n has a binary representations. For example, 8 can be represented as 1000 in binary, 7 as 0111 in binary. The complement of a binary representations is the number in binary that we get when we change every 1 to 0 and every 0 to a 1. So for example, the binary complement of 1010 is 0101. Okay. For a given positive number n in base 10, return the complement of its binary representations as base 10 integer. Right? So it's pretty clear. For the input 10, we should return 5. So the explanation is 10 is 1010 in binary. Its complement is we reverse 10 bit. So we get 0101 in binary, which is 5 in base 10. So we return 5. Right. So in order to solve this problem, let's see. As we know from previous program in this big manipulations category, that that when we saw a number as we all know that when we saw a two different number, we will get a 1, right? When we saw two different numbers, we will get 1, right? So it means if I saw a number with its complement, I will get orbit set, right? For example, this guy 10 1010, so with its complement, which is 0101, this will result in what? So 0 saw 1 is 1, right? 1 saw 0, so two different bits saw two different bits will be 1, right? So same here, 1 0 1 1 0. So we will have 1 1 1 as a result. So that's why I say the result will be always set, right? So here, as you can see, we have complement in one side, right? Here is what we want to here we want to return, right? We need to find this one, right? Num we already know, orbit set we can calculate based on this num, right? So how to so there must be a way to find the complement here, right? How we can calculate it here. One trick to do it here is we can solve num to both sides of these expressions. So we have num solve num, so complement equal to orbit set. And as we discussed earlier, to a number that solve itself will result in 1, right? Sorry, a number solve itself will result in 0, right? And 0 complement 0 solve with any number will be that number itself complement, right? So we can eliminate 0 here, orbit set. Here you want to solve num with both sides of the expressions. So now complement is equal to orbit sets. So with num, right? So here is something we can conclude, right? So in order to find complement, we need to find orbit sets, right? And sort with num. So how to find orbit sets? So let's say, for example, 10. We have 10 in binary is 1010, right? So our goal is to given 10, orbit set will be 111, right? So how to find this one? In order to find this one, we can firstly let me see. Actually, there's a let's see. There's a trick here that makes make our calculations shorter, and this can be further expressed by let's say, sorry, 2 to the 4 minus 1, right? In which 4 is the number of digits, right? Here, this case. Okay, so from these expressions, let's try to find orbit cons orbit set. Okay, this will be 2 to the what? Then number of digits of binary representations. So let's say how we can get it. So for example, we have 10, right? I can convert it into binary using toString, passing 2, which means binary format, right? So this one will return a string. I can count the digits using length. Okay, so this is what we want. Let's copy it and paste it in here. Okay, so these expressions is here. We need to minus 1. Okay, so now return all bit sets. So with num, we will get a complement. Okay, let's run the test. 12, number 3. Okay, it works. So that's it for this complement base 10 number problem. So thanks for watching. See you in the next one.